Okay, we actually have something working. I mean, it really didn't take that long, but yeah, thanks to Johnny's code here, all I wrote was this screen. The actual meat of it is in these, mainly this microcontroller right there, the Pico. Yeah, got some ants crawling around here, but this is the Tesla Model 3. This is a 2018 wrecked vehicle. That's our test vehicle. And one of these USBs actually it's actually just TTL serial going to this display. It's actually powering the display in the back here. The other two are for programming it to the Raspberry Pi. This CAN cable, it's actually just, well, it would be direct plug and play to like a DUIE or Solarc or SunSync inverter. It would be direct plug and play. You just use a Cat5 cable. But because of our Solus inverter doesn't actually have RJ45, it's still not hard, but you just need to, put the blue wire to the CAN H. Yeah, I need to stop the ants. I'm going to seal off this opening and put some ant poison out. But yeah, to get back to it, you can see the high voltage coming in here. These are 1,000 volt 10 gauge PV wire. So they're rated for 30 amps. I mean, I guess it could, in theory, pull more than that. No, this is only 11.5 kilowatt inverter. But we got our AC output. We're actually drawing 29 amps at 240 volts AC, charging a Ford Lightning truck here right now. So through this charger, through this crazy adapter scheme, this is 120 240 split phase US. Oh, there it does. The fan finally came on. This thing is just sitting in the trunk here without any ventilation, so it is getting quite warm at the back, but I'm assuming it has some temperature cutoffs. This is just temporary for testing anyway. Back to the pack here. So this is all plug and play. You can see the shunt connector. That's isolated because the shunt is at the middle of the pack voltage, so it's split in the middle of the pack, and it's isolated with that DC-DC, and it's an I2C shunt microchip. This is the magic. A lot of it is this ISO SPI. So this is a twisted pair isolated. The traces go over to this circuit here, which is our sort of passive decoder. Well, it doesn't decode it. It just changes the logic, the differential logic signals into, the TX and RX and all that. And the Raspberry Pi PIO module does all the magic to actually encode and decode the ISO SPI traffic. Here we got the stock connector, the high voltage sense connector, plug and play. We're only sensing 4 channels, so we're not sensing the middle pack, like after the main contactors. We're skipping that right now. We're just going for the fast charge output, which is over here, and the actual cell voltage, which is right on the pack, like always on. So like 2 of those are always on, and 2 of them are the FC output. They're labeled there. You can see there are some bodge wires here. Just those are the next revision of the circuit board won't have that. This is the first revision of the circuit board. The 12 volt there's 2 separate inputs. They're both the same voltage, though they could in theory be directly in parallel. There's ground and the logic 12 volt and the contactor 12 volt, which accepts 12 to 16 volts. And that is coming from this Meanwell DRC100A, which actually accepts a battery input. So you can actually have your 12 volt battery. This will charge your 12 volt battery and run this for as long as that 12 volt battery. I need to test that, could connect the battery to it, but you basically got your built-in UPS for the BMS here. So even if you had a power outage, you could restart the thing. You could cold boot it up because you need 12 volt to close those contactors. So that's why I would use a power supply like this. And if we look on the other side, so this is the main rewiring. If you notice, the PCS is all disconnected right now. Same for this side, same for the logic input there. And this is live, so don't ever touch what's under there. Well, all of it's live right now, but especially what's under there. Yeah, I mean, those are live pack voltage right now. Probably should have gloves on. Yeah, wear your gloves, people. At least something. Even like these little garden gloves. They're, you know, this will stop 300 volts as long as you don't pierce through it. Better than, I mean, it's better than nothing. I have the giant gloves, but they're so bulky that you can barely do anything with them. I mean, those aren't even as big as some of them get. But at least wear something when you're actually, you know, doing what I'm doing. So you'll notice the big change over here. Because there's no PCS to do pre-charge, and we didn't want to connect directly to the positive or negative pack side because that involves dealing with always live voltages. Whereas in this, the contactor, the FC contactor, which is under there, you can, when there's no 12 volt, that it's off. So both sides of that are off because the main pack contactors, which is under there, are off. I mean, it's safer. You should still wear gloves, obviously, if you're going to touch those bolts. And you should verify with the multimeter that there's no voltage before you do that. But what I've done temporarily is just screwed some wires underneath the positive side, is the far one there. And that's going to our PTC pre-charge setup here that is obviously not permanently mounted. There's some high voltage isolators under that tape. The tape is just in case it did fall over, it would kind of, the bolts aren't exposed. You would need to bolt this. And I'm actually planning to move it to the negative side, which is the closer side there, those two bolts right in the middle. And those, there's actually room next to it. It's not under the wires like the positive one is. So that we could put a circuit board there that would be, designed with these PTCs that would just bolt straight on. So you would just need to loosen those two bolts, put it on, and then, bolt it back down. Then the positive side could just be closed by electric contacts from these LEDs show that I have the fast charge negative one with those jumpers in the top right corner there. Those jumpers are open right now, so it's actually not being driven. It's being driven by that little wire. You can see that little jumper wire is, transmitting 20 amps right now. It's not permanent. But there's, this is all we have to modify in the pack. Do that little change. And I got my temporary, solar PV wires coming out of those two contacts right there, which you could, in the long run, you'd wire it up to the charge port connector. And I got all the connectors removed from this pack right now. But you would wire it up to that input and, isolate every other connector and not have wires just coming into the penthouse like this. And you could also take the PCS out. So assuming you do it like this whole giant PCS can be removed and, sold or used for some other purpose. Potentially you could use that to charge the thing, but that's another can of worms. We might get there someday, but is there anything else interesting? We do have an S3X serial. This could interface with the older S&X pre-2021 battery modules. I'm not sure. We might keep that isolated. We might change that. We got emergency stop inputs on this second RJ45 that they're just disabled in software for testing right now, but there will be an e-stop input and a couple of other GPIO inputs and outputs. Okay, I think that's long enough video.